Combined variation. Combined variation, it involves both direct and inverse variations. In symbol, z is equal to k times x divided by y, or k equals z times y divided by x. Now, you can notice that there is a direct variation here in the numerator and divided by y, which is our inverse variation. And here is the formula for k. By cross-multiplying the x here and the y here. So we get the formula k equals z times y divided by x. It is read as z varies directly as x because this shows direct variation, and inversely as y because it divides into y. Now you have to remember that it is a variation where one quantity varies directly to other quantity and inversely to other quantity. Now try to translate the following variation. Example number 1. T varies directly as A and inversely as B. Alright, the answer is T is equal to K times A. K here is our constant of variation multiplied to A because it is direct variation, and divide into B because it is inverse variation. Now, to find K, cross-multiply B here and A here. So, we get the formula for K, B times T, because we multiply B into T here, and divide by A. Or K equals B times T divided by A. Another example, Y varies directly as X and inversely as the square of Z. You have to note this word, square of Z, meaning you are going to put square into Z here before you divide. So we can translate that into Y. Write down here, Y equals K as our constant of variation, and X here, then inversely means divide to the square of Z. So you're going to put square here into Z. Now to find K, cross multiply Z square here and X. So we can get K equals Y times Z square divided by X, or K equals YZ square divided by X. Another example, translate Z varies directly as X and inversely as Y. Now we have here a given. So after you translate this into mathematical sentence, we can now solve this given. Z equals 9 when X is 6 and Y is 2. Find Z when X is 8 and Y is 12. So we have to translate first this into mathematical sentence. Then solve first this given to find K. Z equals Kx divided by Y. Then substitute the value of Z, that is 9, X is 6, and Y is 2. Remember, the constant of variation here is missing, so we have to solve for the constant of variation. So cross-multiply the 2 here and 6. So 2 times 9, or we can divide directly the 6 and 2. 6 divided by 2, that is 3, because 6 is divisible by 2. Next, K times 3, that is K3 or 3K, then equals 9. Now to eliminate the 3 here, you have to divide both sides by 3. So we can get the value of K by dividing 9 into 3. 9 divided by 3, the answer is 3 equals K, or K equals 3. Now, it is the value of our constant of variation, and we can now write the equation of variation into Z equals 3x over Y. So since this is our equation, and this is the value of our constant of variation, just copy this one and replace K by 3. So this is our equation of variation for this combined variation. Since we already get the equation of variation, which is z equals 3x divided by y, we can find z when x is 8 and y is 12. Substitute the value of x and y to the equation of variation. So we're going to use this equation of variation. So we're going to find z. So substitute x, which is 8. So we have here 3 times 8, and y, that is 12. 3 times 8, that is 24. Divided by 12, we get 2. Therefore, z is equivalent to 2. Another, find x when z is 6 and y is 2. All you have to do is substitute the value of y and z to the equation of variation because we already have here a given for z and y to solve for x. Again, use the equation of variation. Substitute z, that is 6. Okay, and the y here, that is 2. Cross multiply the 2 here because 3 cannot be divided into 2 exactly. So you can cross here the 2. Next, so we have 6 times 2, that is 12. So we have 12 equals 3x. Then to eliminate 3 here, you have to divide both sides by 3. We can now cancel 3. Then divide 12 into 3. 12 divided by 3, that is 4. Thank you for listening, and I have here a quotation for you. I think happiness is a combination of pleasure, engagement, and meaningfulness by Ian K. Smith. Bye!